Let's look at some questions that deal with the normal distribution. Question number 1. Assume z is a random variable with a standard normal distribution and c is a positive number. If the probability of z greater than c is equal to 0.1, then the probability of z between negative c and positive c is equal to 0.8. To answer this question, let's draw a picture. Now I'm going to draw the normal distribution. It has a nice bell curve shape. And we know that if we have some letter C here, the area to the right, since this points to the right, is equivalent to 0.1. Now, if the area to the right of C is 0.1, well, that means the area to the left of negative C must also be 0.1. And the reason I know it's 0.1 on both sides is because we have symmetry. This is symmetric. The z-score equal to 0 is in the middle, and we know that to the right of C is 0.1, so by symmetry to the left of negative C must also be 0.1. Now the area that we're looking for is the area between negative C and C, and so that's the area here in the middle. Now the total area is always equal to 1 because that's 100%. So it must be that this is 0.8. That's the only way to add up all of these areas and get a total of 1. So that's true. The probability of z being between negative c and c is equal to 0.8. So for the first question, this is a true statement. For question number 2, if x represents a random variable coming from a normal distribution and the probability of x is less than 6.1 equals 0.41, then the probability of x being greater than 6.1 is equal to 0.59. Again, I want to draw some pictures to try to understand this question. Let's draw a picture of our normal distribution. I have somewhere on the graph, let's say this is x equals 6.1. Now we know the probability of x being less than 6.1 is 0.41. So let's say this area is 0.41. Now this is the probability of x being less than 6.1. Now we want to look for the probability of x being greater than 6.1. That means the area to the right. So I'm looking for this area to the right. And remember, the total area is equal to 1. So if I subtract 1 minus 0.41, this gives me 0.59. That means this area in orange is 0.59 because that's the area to the right. So the probability of x being to the right of 6.1 is equivalent to 0.59. And that's exactly what this statement says. So question 2 is also true. Question number 3. If a distribution is normal, then it is not possible to randomly select a value that is more than 4 standard deviations above the mean. For question number 3, we'll again draw our normal distribution. Recall the mean is always in the center for our normal distribution. And if we have a perfectly symmetric and bell-shaped figure, the median is also in the center. Now, we know that we can have 1 standard deviation above the mean or 1 standard deviation below the mean. We could have 2 standard deviations where it's mu minus 2 sigma below the mean or mu plus 2 sigma above the mean. And we have also done in our class 3 standard deviations below. We have done mu minus 3 standard deviations, and of course we have already done mu plus 3 standard deviations. And Within 3 standard deviation, it was 99.7%. Now the question is, can we have 4 standard deviations? Well, actually you can. You can have 4 standard deviations. It'll just extend our tail further out, and it will be a very, very small percentage. Remember, 3 standard deviation covers 99.7% of the population. Within 3 standard deviation covers 99.7% of the population. Yes, you can have 4 standard deviations above the mean, but it's very, very rare. It's going to be less than 0.3%. So this is in fact false, because you can have 4 or maybe even 5 standard deviations above the mean. It's just very rare for that to happen. Question number 4. If x represents a random variable coming from a normal distribution with mean 5, and if the probability of x greater than 6.3 equals 0.38, then the probability of x between 5 and 6.3 is 0.12. Again, let's draw some pictures and try to figure this one out. We know the mean is 5. That's right in the middle. The mean is equal to 5. And we know that the probability of x greater than 6.3 is 0.38. So let's say x equals 6.3 here. And I know this area to the right is given to be 0.38. Now we want to check to make sure that the area between 5 and 6.3, that's this area here, that's the area between 5 and 6.3, we want to check to make sure that's 0.12. Now remember, the 5 is right in the middle, so this is 0.5. How do I know it's 0.5? Halfway is 50%, so this has to be 0.5. And it's given that the right side is 0.38. So think about it for a moment. What does this have to be, the area in the middle, so that the total is again equal to 1? In order to figure that out, we can add these two together, 0.5 plus 0.38. And I get this is equivalent to 0.88. And if I subtract that from 1 to find the area between, this gives me 0.12. So this is correct. The area between 5 and 6.3 has to be 0.12. So this is also a true statement. Question number 5. Find the area of the shaded region under the standard normal distribution to the left of the given z-score. So I want to find the area to the left of z being equal to negative 2.2. And for that, we'll use our z-table. So let's go to our z-table. Here's my z-table. I'll have to locate negative 2.2. Here is negative 2.2. So I have negative 2.2, and I want to have the second digit to be a 0. So this is negative 2.20, and so here is my area. Remember, the z-table is always the area to the left, so our answer is 0.0139. So our area is 0.0139. And again, remember, we're looking for the area to the left, the negative 2.20. It's 0.139. For question 6, I want to find the area to the right of negative 0.35. So let's use our z-table again to find this value. I want to find the area to the right of negative 0.35. So we'll look for negative 0.3 first, And then in the column, we're looking for 0.05. So here's 0.05 in the column. And for the row, we'll use negative 0.3. So we'll go down and intersect the row and the column. I get here our solution is 0.3632. So again, we use 0.05 for the column. For the row, negative 0.3. Our solution is 0.3632. Now be careful. Be very, very, very careful. That was the area to the left. The area to the left was 0.3632. The area to the left is 0.3632. We're not looking for the area to the left. We're looking for the area on the right side. So we'll have to figure out what this is, and to do that we'll subtract from 1 because the total is 1. I can subtract what I don't want. So 1 minus 0.3632 is going to give me the area on the right. And that is 0.6368. So our solution for the area to the right of negative 0.35 is 0.6368. For question number 7, let's find the area in the shaded region under the For question number 7, let's find the area of the shaded region under the standard normal distribution between the given z-squares. Round your answers to 4 decimal places. For the first part, I want to find the area to the left of z being equal to negative 0.79. So let's look at our z table for negative 0.79. So for the row, we're going to look at negative 0.7. And for the column, we're going to look for 0.09. So let's intersect the row and the column to find the area to the left of negative 0.79. That is 0.2148. So I know this area is so the area to the left is 0.2148, and that's to the left of negative 0.79. Now we'll look for the area to the left of negative 0.29. The area to the left of negative 0.29 is going to be this area here. So please use your z-table, find the same number, is 0.3859. So our area is 0.3859. So the area to the left of z being equal to negative 0.29, from here all the way to the end is, again, that number is 0.3859. 0.3859. Now, I want to find the area between them. I don't want to find the area to the left of both of these. I have to do a subtraction. Now, the easiest way to remember this is to subtract the bigger number minus the smaller number. So I'm going to do 0.3859 minus the area of the smaller one. That's 0.2148. Now let's simplify this. This is equivalent to 0.1711. And that is the area between these two z-scores. Question 8. Adult male height is normally distributed with a mean of 69.2 inches and a standard deviation of 2.32 inches. If an adult male is randomly selected, what is the probability that the adult male has a height greater than 74 inches? Round your final answer to 4 decimal places. So to do this question, we'll have to use the z-score formula. Z equals x minus mu divided by sigma. X is our data value. Here we want to find an adult male that has a height greater than 74 inches. So I want to find the probability of x being greater than 74 inches. Now I don't have an x table, but we do have a z table. So let's convert this x to a number that is a z. So we'll use the z-score formula. Z equals x is 74, and the mean is 69.2. We'll divide that by the standard deviation, which is 2.32. Now let's calculate our z-score. And when you enter this in a calculator, just be careful. Make sure you put parentheses on the top so you can get the correct number. So this z-score is 2.07. So my z-score is 2.07. That is going to replace this expression here. This is equivalent to the probability of z being greater than 2.07. So we converted from an x into a z, our standard normal distribution. From here, now I can use my z table and I can calculate the area to the right. Notice that this is the area to the right of 2.07. So I'm going to subtract. We're going to subtract from 1 to figure out what this area is. So 1 minus, now I'll have to find the area to the left of 2.07. So for 2.07, we'll go to the positive side of our z table. And here is 2.0. And we'll look for 0.07. So let's intersect the row and the column. And so this is our area, 0.9808. Now remember, that's the area to the left, 0.9808, but I want to look for the area to the right. So we'll have to subtract from 1 here, and this gives us 0.0192. So the probability that a male is greater than 74 inches is about 0.0192 or 1.92%. So it's very rare to have a male that is above 74 inches. For question number 9, the combined SAT scores for the students at a local high school are normally distributed with a mean of 848 and a standard deviation of 151. The local college requires a minimum SAT score of 852 before students are considered for admission. What percentage of students from this school have SAT scores that satisfy the local college admission requirement? Enter your answers as a percent accurate to 2 decimal places. So let's use the formula again for z-score. Z equals x minus mu divided by sigma. In this case, we have the mean is 848. We have the minimum score that we need is 852, so that's x. This is mu. The standard deviation is 151, that's sigma. So I can plug it in. We have 852 minus 848 divided by 151. So the z is equal to, let's plug it in our calculators. Again, don't forget the parentheses. And this gives me a z-score of 0.03. Now I want to find the probability that somebody's z-score is greater than 0.03. So we want to find the area to the right because we won't accept anybody who scores less than a z-score of 0.03. So let's go to our z table and find the area that's the closest to 0.03. We have 0.00 and then 0.03. So the area is 0.5120. Now remember, this is the area to the right, so we'll have to subtract from 1. This is 0.5120. Again, that's 0.5120 because we don't want the area to the left. We want the area to the right, so we'll have to subtract from 1. And so the percentage or the number is 0.488, which is equivalent to 48.8%. So this school is going to accept about 48.8% of those that took the SAT exam. Question number 10. Crystal and Gabriel began arguing who did better on their tests, but they couldn't decide who did better given that they took different tests. Crystal took a test in art history and earned a 77.3, and Gabrielle took a test in social studies and earned a 65.7. Use the fact that all students' test grades in the art history class has a mean of 73.6 and a standard deviation of 10.1. And all the students' test grades in social studies had a mean of 66.2 and a standard deviation of 10.2 to answer the following questions. Calculate the z-score for Crystal's test grade and calculate the z-score for Gabrielle's test grade. We'll have to use the formula z equals x minus mu divided by sigma for both of the individuals. We know Crystal's test score was a 77.3, so that's x, 77.3 minus, and the mean for the art history class was 73.6 divided by the standard deviation of 10.1. And for Gabrielle's test, she had a score of 65.7. And the mean for the class was 66.2. And we're going to divide that by the standard deviation of 10.2. So let's enter these in a calculator. Be careful. Make sure you use parentheses for the top. And then you can divide by the bottom. This gives me a z-score of 0.37. And this one gives me a z-score of negative 0.05. So who did relatively better? Well, it's going to be the person with the higher z-score. They're above average. Gabrielle's test score was below average. So we know that Crystal did relatively better. Remember, the z-score represents the number of standard deviations above or below the mean. In this case, Crystal did 0.37 above average standard deviation, and Gabrielle did negative 0.05 standard deviations below average. So she did poorer than average. In question number 11, we're going to use technology because this question will take us a long time if we have to do it by hand. So let's use technology. The weights of a certain dog breed are approximately normally distributed with a mean of 51 pounds and a standard deviation of 6.8 pounds. And now for part A, we want to find the percentage of dogs of this breed that weigh less than 51 pounds. So for part A, I'm looking for the probability that X is less than 51 pounds. We know the mean is equal to 51, and we know the standard deviation is equal to 6.8. So let's go to our computer and enter those numbers. Here I'm going to enter the mean. The mean is 51, and we know the standard deviation is 6.8. I'm going to calculate below, and we want to be below 51 pounds. So let's push below 51 and recalculate, and it's 0.5, which makes sense because that's right in the middle. That's below 51, which is the mean. so it is 0.5 or 50%. So we have this is equivalent to 0.5. For part B, we want to find the percentage of dog breeds that weigh less than 49 pounds. So I'm looking for the probability of X being less than 49 pounds. So the only thing we have to change is the 49 pounds. So we'll enter below 49. Click recalculate, and here is our probability, 0.3843. So we have 0.3843. There's a 38.43% chance. Now we know that 38.43% of this breed will weigh less than 49 pounds. For part C, we want to find the probability that this breed weighs more than 49 pounds. So we're looking for the probability of X being greater than 49, and we could do it several different ways. We could take the part B and subtract it from 1, or we could just use our calculator. So let's go to our statistics calculator, and I want to be above, and we'll enter here 49. Click recalculate, and you get 0.6157. So our solution is 0.6157, and that is equivalent to 61.57%. So we know 61.57% of this breed will weigh more than 49 pounds.